math. Chapter number is 1. Chapter name is rational numbers. So let us start its introduction. Before this, number system. Number system. See, number system is of two types. One is real number. Number systems is of two types. Real number system and complex number system. Complex. Real number. Number is of two types, real number and complex number. Okay. In real number, we will discuss natural number, whole number, and integers, then rational number, and irrational number is also, and irrational number. Natural numbers are denoted by n. In this video, we are not going to discuss this complex number. Whole numbers are denoted by one by one. We will discuss these numbers, definitions and examples. Okay. Before this, again see, first of all, number is of two types, real and complex. In real numbers, natural number, whole number, integers, rational numbers, and irrational number system. Okay, see. First of all, natural number. Natural number denoted by n. What are natural number? The real number which starts from 1 and goes to infinity. Natural numbers are those real numbers which starts from 1 and goes to infinity. Okay. After that, whole number. Let us use its notation whole, denoted by W. These are such real numbers which starts from 0, 1, 2 and up to infinity. Okay. After that, integers. Integers are denoted by Z. These are real numbers. These are whole numbers along with their negatives. -1, -2 and minus infinity, up to minus infinity. These are integers. After that, rational numbers. What are rational numbers? Rational numbers are denoted by Q. The real numbers which can be written in P by Q form, where P and Q are integers and Q is not equals to 0. Such numbers which can be written in P by Q form and Q must not be equals to 0, and where this P and Q are integers. So what could be its example? 1 by 2, 3 by 5, 0, 1, -5. These all are examples of rational numbers. These all are of examples of rational number. Okay, these before doing irrational number, after this we can discuss irrational number. Irrational numbers are denoted by I. Irrational numbers are denoted by I. See, these which numbers are not rational, that are irrational numbers. The real number which are not rational numbers, which we can't write in P by Q form, that are irrational number. Example, like a √3, a √2. These are irrational numbers. We can't write these in P by Q form because P and Q must be integer, and where these root 2, root 3 are not integers. Okay. These all numbers, natural number, whole number, integer, and rational numbers are in real number system. Are in real number system. These all are. Irrational number is also included in real number system, but one pattern we will see there. That's why I have written separate. See, natural numbers starts, the real number will starts from 1 to up to infinity and goes to infinity, and whole numbers are 0, 1, 2 up to infinity. We can see all natural numbers are whole number. All natural numbers are whole number. But if I will see its converse, reverse, all whole numbers are natural number. No. This because 0 is that number which is not in natural numbers. So we can say all natural numbers are whole number, but all whole numbers are not natural numbers. Further, we can say all natural and all whole numbers are included in integers, but all integers are not whole. All integers are not natural numbers. Okay. Now these all natural, whole, and integer, these all are counted in rational numbers. These all are rational numbers. Okay, let us see definition of rational number now. What is definition of rational numbers? The real numbers which can be written in form of P by Q, where Q is not equal to 0 and P and Q are integers. Examples are 2 by 3, 8 by 17, minus 3 by 4. And many more examples we can write 0, 1, minus 5, 3. These all are examples of rational numbers. Let us discuss about this 0, how it could be a rational number. We can write this 0 by 1. Our condition is fulfilled. Any number, the real number which can be expressed in P by Q form. So I expressed this 0 in 0 by 1 form, this P by Q form. And my condition is as it is, Q is not equal to 0. It means this 1 is non-zero there. Okay, and 0 and 1 both are integers. So this 0 is fulfilling all requirements for the rational number. That's why this 0 is also a rational number. 1 by 1 we can write, minus 5 by 1 we can write, 3 by 1 we can write. Not necessary 0 by 1 we can write. Any other denominator we can consider, 0 by 10, 0 by 15, and 0 by minus 18. Any numbers. Okay, rational numbers, the real numbers which can be expressed in the form of P by Q, and Q is not equal to 0, where P and Q are integers. Remember these conditions, P and Q are integers and Q must not be equals to 0. Then such numbers we can call rational numbers. Okay, now after this, there are some properties which we need to discuss of rational numbers in this section. See, what are that property of rational number? First one is closure property, second one is commutativity property, third one is associativity property, and fourth one is distributive property. These are the four properties that we need to discuss for rational numbers. One by one we will discuss. Let us start from closure property. What is closure property? This closure property, closure property. Closure property. What is closure property? This closure property, under four operations we will discuss. Closure property we are going to discuss under four operations: addition, subtraction, multiplication, and division. And four we will discuss for whole number, whole numbers. Then we will discuss this property for integers, and at last we will discuss it for rational number. Rational number. One by one we will discuss. Let us start from whole numbers. For whole numbers. Now see, what are whole numbers? We know the real number which starts from 0 and goes to infinity. That are whole numbers. Now see, closure property for whole number under four operations: under addition, Addition under subtraction, under multiplication, then under division. Under these four fundamental operations, we are going to discuss closure property for whole numbers. Okay, these are operations. Okay, now their examples we will discuss. Examples, and then what we conclude from this, that should be written there. Conclusion. Conclusion. Okay, see what is closure property for whole number. Suppose I will take two whole numbers. I will take two whole numbers. If I will add them, then again my answer should belongs to whole number. This is closure property under addition. Consider two examples from whole number, two numbers from whole numbers. Let A and B belongs to whole number. Then according to my closure property, if I will add these two numbers, then again my answer should belongs to whole number. Okay, let us check it by particular example. Let A equals to 2 and B equals to 3. Okay, both are whole numbers. Add these 2 plus 3, answer is 5. 5 further belongs to whole numbers. So what we can say? Addition is closed for whole numbers. Addition is closed in whole numbers. Addition is closed. Addition is closed in whole number. For whole number we are discussing, it will be understandable. Addition is closed. Further, same property we will discuss for subtraction, under operation subtraction. For whole numbers, let A and B belongs to whole number. Then according to this property, their subtraction must belongs to whole number. If this subtraction belongs to whole number, then we will say subtraction is closed for whole numbers, otherwise no. Let us verify this with particular example. Let A equals to 2 and B equals to 3. A equals to 2 and B equals to 3. My answer is -1, which not belongs to whole number. -1 is not a whole number. -1 is not a whole number. It means it doesn't belongs to whole number. What is our conclusion? Our conclusion is subtraction is not closed. Subtraction is not closed in whole numbers. In whole numbers. This is our conclusion. Subtraction is not closed in whole numbers. Okay. Now further, under operation multiplication we are going to check. Same. Let two numbers A and B which belongs to whole number. If I will multiply them A into B, then again my answer must belongs to whole number. If it is so, then we can say multiplication is closed, otherwise no. Then again particular example, let A equals to 3, B equals to 5. Okay, multiply 3 into 5. 3 into 5, answer is 15. 15, again it belongs to whole number. So what I can say, what is our conclusion? Multiplication is closed. Multiplication is closed in whole numbers. Multiplication is closed in whole numbers. Now for division, under operation division, this closure property. What we can say for division? Let same pattern, A and B belongs to whole number. We consider this example, A and B are two numbers which belongs to whole number. Then A divided by B must belongs to whole number. Let us verify. Let A equals to 3 and B equals to 10. B equals to 10. So 3 divided by 10. Answer is 3 by 10, which doesn't belongs to whole number. Which doesn't belongs to whole number. So what is our conclusion? That division is not, division is not closed. Division is not closed in case of whole numbers. In case of whole numbers. Okay, let us take a quick revision. Closure property for whole number we are discussing under 4 operations. What are operations? Addition, subtraction, multiplication and division. Examples are, what are property? Under addition we want to check, take two numbers which belongs to whole number. If I will add them, then my answer must belongs to whole number. Add these two numbers, a plus b, then it must be again a whole number. Let us verify it by taking example. A equals to 2, b equals to 3. 2 plus 3 is 5, which is again a whole number, it belongs to whole number. Its mean addition is closed. Addition is closed. Then let a and b belongs to whole number, and then a minus b. Under subtraction we want to check, then their subtraction must belongs to whole number. A equals to 2, b equals to 3. Then you go to minus 1. Minus 1 doesn't belongs to whole number. So we can say subtraction is not closed. Similarly, we checked for multiplication. Multiplication is closed and addition is not closed. Okay. Now this property we are going to discuss for integers. For integers. Closure property. For integers. For integers. Okay, same pattern. This closure property for integers we will discuss under 4 operation. Under 4 operation. Operations are addition, subtraction, multiplication and division. And division. See, their examples we will write. Examples, and then their conclusion we will write. What will be our conclusion? Okay, see. For a closure property for integers under addition. Same. There we were taking examples from whole number, and now we will consider two numbers from set of integers. Let a and b belongs to integers. A and b belongs to integer. Now under addition, if I will add these two integers, then further my answer must belongs to integer. Okay, let a is minus 2 and b equals to 3. Let's verify. It's minus 2 and b is 3. Answer is 1. 1 belongs to set of integer. Again 1 is integer. So what we can say, integers are closed under operation addition, or addition is closed in case of integer. Addition is closed in case of integer. In case of integer, addition is closed in case of integer. Now, same property under operation subtraction we will discuss. Same, let a and b belongs to integer, and then their subtraction again must belongs to integer. If it is so, then we can say subtraction is also closed in case of integer. Let us verify by taking particular example. A equals to 3 and b equals to minus 2. Then a minus b, what is value of a? A is 3, b is minus 2. What is answer? 3 plus 2, answer is 5, and 5 further belongs to integer. 5 further belongs to integer. So we can say subtraction is closed. Subtraction, what our conclusion arrived? Subtraction is closed in case of integer. Subtraction is closed in case of integer. Okay, let us discuss for multiplication. Let a and b belongs to integer, then their multiplication must belongs to integer. If it is so, then multiplication is closed in case of integer. Consider example, a is 5 and b equals to minus 3. Okay, a into b, 5 into minus 3, answer is minus 15, and minus 15 belongs to integer. Minus 15 belongs to integer. Its mean multiplication is also closed. Multiplication is closed. Multiplication is closed. Now for division, consider two examples, two numbers from set of integer. Let a equals to minus 2 and b equals to 3. Then a divided by b must belongs to integer. Let us verify. Minus 2 divided by 3. Answer is minus 2 by 3, which doesn't belongs to set of integer. So we can say divisions are under operation division. Integers are not closed. Division is not closed in case of integers. Divisions are not closed in case of integers. Thank you.